All right. Compare your plotted data points to what LoggerPro came up with. Look up here, you can see where LoggerPro placed the 6 points. Hopefully yours looks something like that. Same general trend. And now the question is what to do next. We plotted all the data. And if you didn't finish plotting it, just keep doing that as we go along here. So you have it to work with. But once all the points are plotted, which of these three choices describe what you do next? Yeah, the majority of you correctly said what you draw depends on what your data set looks like. One thing you never ever do is connect the dots with straight line segments. Right? Scientific graph is just not the way it's done. Now, financial graphs, if you're talking about what the stock market's doing or something like that, oftentimes they will do that. They'll show that, you know, in this particular day we were here, the next day we were here, next day we were there, and they'll just kind of do something like that. But we never do that with a scientific graph. We're always going to do something that's nice and smooth with no sharp corners like that. And it's either going to be a curve or a straight line. What we want to do, if the points appear to be related linearly, then we want to draw what's called a best fit line through them. And a best fit line is a line that's kind of an average of all those data points showing what they would do. Right, it represents an average of the points. Does the best fit line have to touch any of the data points? You're drawing that line, because in this case they do appear to be related linearly. Would everybody agree with that? Looks like kind of a straight line. Why wouldn't it be perfectly straight? You collect a bunch of data, what would keep it from being a perfectly straight line? Any ideas, Trevor? In other words, here's what I'm saying. Let me draw a sketch of this, because you may not understand the question, because I'm not sure it was very clear. I'm saying this: if we plot points, it'd be possible for every last point to be on the same straight line. But if you look at your data that we just plotted, I think you'd find that, in fact, you try that, putting your straight edge through them, it's not going to hit all the points. See that? So my question for all of you is, what would cause it to not be a perfect straight line? Because it'd be really, really weird if you guys went in the lab and you got something that was perfectly straight, that a line went through all those points. And I'll give you all a hint. The answer starts with an E, and it's something you can't avoid. Every experiment's going to have it. Right, Matt? You're going to have error. That's right, experimental error. That's the reason why it's not going to be perfectly straight if it's supposed to be. So back to your answer to this. 95% of you said no, it doesn't have to touch, and that's true. That's correct, right? The best fit line doesn't have to touch any of your data points. What you're shooting for is a line that has roughly the same amount of data points on one side of it that it does the other. You want to kind of run it down the middle. Does your best fit line have to go through the origin? The answer is no, it does not need to go through the origin. Right? What you're looking for is something that kind of splits the difference. Let me just draw a sketch of it up here to show you what I'm talking about. These are my axes, and these are my data points. Let's say my data set looks something like that. My best fit line would simply be a line that would kind of split the difference of those points. So we have roughly the same number of points on one side of the line that we have on the other side of the line. Right, just kind of averaging out what all those points are showing us. That's what you're after. And actually, let me not show you that yet. I want you to draw your best fit line for your data points. See what yours look like, and then we're going to compare it to what LoggerPro came up with and see if yours looks like anything like theirs. Remember, it doesn't have to touch any of them. Doesn't have to go through the origin. Kind of average it all out, and now compare it to what Logger Pro found. And if you look at Logger Pros, their first data point's a little above the line, the second one's a little below, the third one's almost dead on, fourth one a little above, fifth one a little below. Everybody's going to have a slightly different best fit line because your estimation of what is best is going to be different than somebody else's. When the computer does a best fit line, it is truly the best fit line. Anybody know how the computer comes up with its line? Because I know many of you have done linear fits before if you did graphs in chemistry. Caitlin, yeah? Well, the slope is something we're going to be calculating in just a minute, but you have to, if you knew what the slope was supposed to be, then you would know how to make it, right? But how you draw that best fit line is going to determine the slope. So unless you know what the slope is supposed to be, that doesn't help but determine where to draw that best fit line. Any other thoughts? Let me just give you a real brief explanation of how it does it. What it does is it plops the line down there any old place, and it measures how far away each data point is from the line. It measures the distance from each point to the line. It squares all those distances because some are negative, some are positive, because some are above the line, some are below, and it adds them up. And it looks at that value, looks at how big it is, and then it adjusts the slope and tries it again. And it keeps doing that until the sum of all those squares of those differences is a big number or a small number. As small as possible. It's trying to minimize the difference between the line and the point locations, and it does that like that instantly. I mean, for you or me to do that, I took a statistics course in college where we actually had to do that by hand. It's a long process. I can remember spending like a half an hour on it just trying to arrive at the best fit line. So when you do this by hand, you're just going to give it your best guess. You're going to sketch it in there and try to get it right. Understand, though, that points will not always form a line. There will be times where you'll need to do a curve instead of a line. And again, you don't connect the dots with line segments. You draw a smooth curve, which kind of averages out all of the data points. It doesn't have to touch any of the points. This represents an average. Here's a chemistry example. And I will actually give a joule to the person who remembers this law from chemistry. All right, what's the law in chemistry that talks about what happens to the pressure of a gas as its volume changes? And boy, I saw several. I think, was Caroline's hand up before? Because I saw Sabrina, yours too. And then I saw a bunch of other people, but Caroline, remember? That's Boyle's law. Sabrina, is that what you were going to say? Did you happen to look and see whether she was up before you, or? I'll give you both a joule, right, at the end of class. Well, yeah, that's Boyle's law. It says pressure and volume are inversely related when the temperature is held constant. And obviously, you wouldn't draw a straight line through that because it's curving. So you're looking for the best fit curve. Caitlin, you mentioned slope. That's going to be our very next job. So tomorrow, before we start the lab, we're going to look at how to calculate the slope of this thing. All of you know what slope is because you've calculated in math class. There are a couple differences between what you did in math class and how we're going to do it in physics, so we're going to take some time to do that.